I'm Anil Kumar sharing with you three important questions as a test review on the concepts which we learned in part 1 and part 2 of trigonometry dealing with compound angles. Basically converting sum and difference formulas to product of sine and cosine. These three questions are 1. 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 equals to 0. Second one is sine 5x minus 2 sine x 3x plus sine x divided by cos 5x minus cos x equals to tan x. And the third one is tan 5x plus tan 3x divided by their difference is 4 cos 2x cos 4x. I'd like you to pause the video, answer all these three questions, and then look into my suggestions. That will be an excellent review for all the formulas which we have learned so far. To give you a hint, in the first you have an option. You can write this product to cos A cos B using the formula, which I hope you remember. Let me write down the formula here for you, which is cos A plus B plus cos A minus B is equals to 2 cos A cos B, correct? That should help you to solve this particular question. And in this case, we see difference, right? So you could use the formula which relates the difference into product. That should help you. So for that, you could use the formula. Let me write down here. Cos C minus cos D is equals to minus 2 sine C plus D by 2 sine C minus D by 2, right? So that is from difference to product formula which you could use to solve question number 2. So that is hint for 2. This is hint for question number 1. And here you have to use sum and difference. Basically, the basic formulas which relate sine A plus B as sine A cos B plus cos A sine B, right? Cos A sine B. You may also need double angle formulas, which is sine 2A equals to 2 sine A cos A to solve this particular question, right? So I hope these formulas are well applied and you get your results. I'll now begin with their solutions. So let's take them one by one. Now let's solve the very first test question, which is we need to prove that 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 is equal to 0. Now here we have product form. We could change product to sum. And to do that, I hope you remember the formula about cos A plus B. We'll start with the compound angle formula, which is cos A cos B minus sine A sine B. And if we have cos A minus B, you could write this as cos A cos B plus sine A sine B. Now, if you add them up, right? If you add them up, right, what do you get? If you add them up, you get cos A plus B plus cos A minus B equals to twice cos A cos B, correct? So this term twice cos A cos B, you can treat pi by 13 as A and 9 pi by 13 as B. And then you can apply this formula, correct? So we'll apply this formula right there and then prove this particular identity. That is the strategy. So you can pause the video at this stage and then solve and check with my solution. So I'm replacing the left side, which is twice cos pi by 13 cos 9 pi by 13 as cos A plus B plus cos A minus B, correct? So I could write this as cos of A is pi by 13 plus 9 pi by 13. Do you see that? Plus difference of these, which is cos pi by 13 minus 9 pi by 13. So with that, I have replaced the product as sum. So it's reverse, right? And I'll maintain this portion as such. So which could be written as cos 3 pi by 13 plus cos 5 pi by 13. We have to show that this is equal to 0, correct? We are beginning with left side. Now if you do this, what do you get? You get cos of 9 plus 1 is 10, you get 10 pi by 13 plus cos pi minus this is minus 8 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. Now here we can apply our knowledge about the relations, right? Related angles. So as you know, in the coordinates, if I have, let's say, a triangle here with the angle theta, and here we have, this is 10 pi by 13. Okay, so 10 pi by 13, let me rewrite this as, so it is 10 pi by 13 could be written as pi minus 3 pi, right? You can say 13 minus 10, 13 minus 3, or you could say pi minus 3 pi by 13. Does it make sense to you? So you could write it like this, right? Now as far as cosine is considered, this minus 8, now minus of cos is actually positive, correct? Either way you could write. You could write 9 pi minus 13, and cos is even, right? Even function. So you could write this as cos of pi minus 5, right? So you could say cos pi minus 5 pi by 13. And we just continue writing the others as cos 3 pi by 13 plus cos 5 pi by 13. So what I'm trying to say here is, if you consider an angle which is pi minus something, theta, let's say, so that's the angle which is pi minus theta, then cos is negative in this quadrant, right? So as you know from the rules that cos is actually positive here and in first quadrant, here sine is positive and tan is positive in quadrant 3. So in that quadrant, cos is negative, and therefore you could write this as negative cos 3 pi by 13. And here you could write this as negative cos 5 pi by 13. And what you already have here is cos 3 pi by 13 plus cos 5 pi by 13. Do you see that? So now you can see that they cancel off, and this indeed is equal to 0. Do you see that? So that is how you can show it. Now the question for you is, how did I come from here to this place? Now let me just show you there separately. It might be a confusion. So when we say cos of minus 8 pi by 13, it is also equals to cos of 8 pi by 13. Since cos is an even function, right? Now 8 pi could be written as 13 minus 5, right? Okay, 13 minus 5 over 13 pi. Do you see that? Now 13 over 13 is 1, and so we got this as cos pi minus 5 pi by 13. So these were the steps involved when I moved from this stage to that. And similarly, you could think in similar lines as you move from here to there. Is it okay? So that is how you should be doing it. So I hope these steps are absolutely clear, and we have used just sum and difference to product form to get the result. Correct? Now we'll take up the next example, which is sine 5x minus 2 times sine 3x plus sine 3x divided by cos 5x minus cos x equals to tan x. So you can pause the video, answer this, and then look into my suggestions. Now let us solve this particular question. We'll begin from the left side, which is given to us as sine 5x. We'll just rearrange. We'll bring sine x first. So we'll write this as plus sine x minus 2 sine 3x over cos of 5x minus cos x. Correct. Now as you can see here, the portion which I am showing as this sum, and here we have a difference, we could apply the formulas which we have learned. That is, sum of sines, let's get back to this. Sum of sines is the very first formula, and difference of cosines. So difference of cosines is this formula, right? Minus twice sine sum divided by 2 times sine difference divided by 2. We will not get through this derivation, as then the solution will be very lengthy, right? So as I was saying, we'll apply the formula to convert from sum to product in the numerator. So sine 5x plus sine x could now be written as sine of their sum divided by 2, which is 5x plus x divided by 2, right? Twice, times cos of their difference, which is 5x minus x divided by 2, and we already have minus 2 sine 3x. You get an idea, right? Divided by, in the denominator, we have difference of these two, right? Cosines. So that will be minus 2 times cos sine of their sum. It's better to write sine of their sum first, which is 5x plus x divided by 2 times sine of their difference, which is 5x minus x divided by 2, right? So we directly applied the formula to convert from sum or difference into product. Now the numerator gives us twice 5 plus x 6 divided by 2 is 3, so it's sine 3x, and here we get cos of 4 divided by 2 cos 2x minus 2 sine 3x divided by, so here we have minus 2 sine of 3x sine of 2x. Correct. Now sine 3x is common, so we can take 2 sine 3x rather is common, so we'll take 2 sine 3x common. We are left with cos 2x minus 1 divided by minus 2 sine 3x sine 2x. Correct. Now at this stage we can cancel 2's, and we can also cancel sine 3x sine 3x. So let me take it to the right side to further simplify. So what we get here at this stage is, here we have a negative sign. Correct. We have a negative sign here, so we could write this as 1 minus cos 2x divided by sine 2x. Do you see that? Sine 2x. Sine 2x. So here you will see we have used the formula which converts sum to product, and now we have a double angle formula to apply. Do you see that? So we should now apply the double angle formula. What is 1 minus cos 2x? What is 1 minus cos 2x? You learned 3 formulas for cos 2x. Let me rewrite those 3 formulas. So cos 2x is equals to cos square x minus sine square x is also equals to 2 cos square x minus 1. I hope you remember this, right? And is also equals to 1 minus 2 sine square x. Correct? So, so these are the 3 formulas for cos 2x. Now, which one to apply? we will do denominator first. Sine 2x is just one formula, which is twice sine x cos x. Twice sine x cos x. Now, 1 minus cos 2x, if I use this formula, correct, then we know what is 1 minus sine 2x is. So if I print this, let's rearrange this particular formula, right, which is cos 2x equals to 1 minus 2 sine square x. Bringing it to the left side gives us 2 sine square x equals to 1 minus cos 2x. Do you get an idea? So 1 minus cos 2x can be written as twice sine square x. So I'll write this as twice sine square x. Do you see? That is how you could rearrange. Or you could have expanded the numerator also. 1 is cos square x plus sine square x. Cos 2x is cos square x minus sine square x, and you get 2 sine square x. Correct? So either way. So I'm just trying to remind you what formulas you've learned so that we could apply them. Now there's 2 and they cancel off. And what we are left with is sine x over cos x, which is tan x, or our right side. Correct? So this is an excellent example seen in test papers. I'd like you to copy this particular question and its solution, understand, and then move on and do the last question in this series, which is tan 5x plus tan 3x divided by tan 5x minus tan 3x equal to 4 times cos 2x cos 4x. Now here is the third and the last question from our test review. We need to prove tan 5x plus tan 3x divided by their difference is 4 times cos 2x cos 4x. We'll begin from the left side and write tan in terms of sine and cosine. Right, so tan 5x could be written as sine 5x over cos 5x. Similarly, tan 3x can be written as sine 3x over cos 3x. And denominator also will do the same. Sine 5x over cos 5x, difference sine 3x cos 3x. Now take common denominators in both numerator and denominator. So if I take the common denominator, let's say they get multiplied. So we get sine 5x cos 3x plus cos 5x sine 3x over their product, which is cos 5x cos 3x, correct? Similarly, in the denominator, we get product of sine 5x cos 3x, take away cos 5x sine 3x, and the product of cosines, cos 5x cos 3x. The denominators, as you can clearly see, cancel off, right? With the result, what we get is ratio of these numerators, right? So which is sine 5x cos 3x plus cos 5x sine 3x divided by their difference, sine 5x cos 3x minus cos 5x sine 3x, which reminds you of the formula which is sine A plus B. So you could write this as sine 5x plus 3x, and here we have difference sine 5x minus 3x, right? Now that is equal to sine 8x over sine 2x. Now what do we need to prove? We're looking for cosines 2x and 4x. Now, okay, so in the numerator, we could apply the formula of double angle formula, which is, let me write down the formula first. Let me write down here. If I have sine 2 theta, I could write this as 2 times sine theta, cos theta, right? Here we have 8 times. So half of 8 is 4, right? So I could write this as twice sine 4x cos 4x. We'll keep denominator as sine 2x. Now cos 4x, we already got one term. We can split sine 4x using this formula once again. So it gives you 2 times, and sine 4x could be written as, let me write down as 2 sine 2x cos 2x. And we'll maintain cos 4x as such. Does it make sense to you? We have sine 2x in the denominator. Now sine 2x cancel. 2 times 2 is 4. So we get 4 cos 2x and cos 4x, which is the right side. Is it okay? So this is how you can actually prove this identity. So I hope you learn in this series how to derive the formulas and also how to do questions based on these formulas. Thanks for watching and all the best.